can go. Okay, so this is what you've missed this week. First of all, you have a sequence, which is a set of numbers that follow a pattern. You probably already knew this, but we covered it this week. And then a series is adding the numbers in a sequence together. Okay? So a geometric sequence is going to be a sequence that each term is multiplied by a common ratio in order to get the next term. So an example of this would be like the sequence 1, 3, 9, 27. As you probably have noticed, each term is being multiplied by 3. Therefore, the common ratio is 3. This is important to remember when we get to formulas. And another thing is the arithmetic sequences. These are adding the numbers in the sequence. So you have a constant for what you add the first term in order to get the next term. An example of this is 1, 2, 4, 6, and 8 as a sequence, and the constant is 2. Next, we have recursive and explicit functions. Recursive is going to be like your now next rules. So in order to get the desired value, you must go through each term of the sequence. So for example, you'd have like next equals now plus 2 starting at 1. This form is going to be a little more tough if you're trying to find one certain term in your sequence. If you're, let's say you're trying to find the 5th term, then you're going to have to go through each step instead of just plugging 5 into the equation and then finding what that term is, okay? And then you have explicit, which is like your y equals functions. So you plug in the values to get your desired solution without having to go through the pattern. So for example, you have like y equals 2x, or p sub n equals 2 to the power of p sub n minus 1. This is easier, so like I was saying before with recursive, if you were wanting to find the 5th term in the sequence, then all you have to do is plug in 5 for x and you'd figure it out. Now, but for this, like I said before, you're going to have to go through each step. Next we have our formulas. This is Gauss's formula, which you would use in order to find the accumulated sum of your arithmetic sequences. Arithmetic sequences being the ones that you're adding as a constant to find each next term. And you do this by taking the initial term plus the final term, and then the number of terms, you multiply that by the number of terms, and then you divide everything by 2. So an example of this is, let's say you have the sequence of 1, 2, 3, 4, 5, and you're trying to find the 5th term. You would take the initial term, being 1, put it here, and then the last term, which is 5, so put it here, and then you multiply it by your number of terms, which is 5, so it's here, and then you divide it by 2, and then you end up getting 15. So that's how you find the accumulated sum of an arithmetic sequence. Now, finding the accumulated sum of a geometric sequence is different, but this is the formula you'd use. R to the power of n minus 1 over r minus 1. Remember, r is our common ratio, and as I said before, the common ratio is what you're multiplying your first term in order to get your next term. And n is the term in the sequence you're trying to find. So for example, let's say you have the sequence before that we were doing right here, 1, 3, 9, 27, where your common ratio is 3. Then what you do is you'd plug in 3, your common ratio, right here, and right here, r. And then all you have to do is, let's say you're trying to find the 5th number in the sequence, you plug in 5 for n, and there you go. You'd find what your 5th number in the sequence is. But when it's a little trickier and your starting value isn't going to be 1, then you have to multiply this equation by your starting value. So an example, or the symbolic way of writing this would be b multiplied by r to the power of n minus 1 over r minus 1. And that's what you missed this week. I hope you enjoyed the video. Thanks.